All right, here's section 1.3, Introduction to Experimental Design. Maybe. Okay. All right, so basic guidelines. Obviously, this is in your notes, so you can kind of read through this, but first we want to identify individuals or objects that we're studying. What are the variables, as well as protocols? So how are we going to take measurements or make the observations? Are we going to use an entire population or try to use a sample? What is our plan for data collection? Identify other things, kind of those sampling models that we've been talking about in 1.2. Collect our data, and then we want to use our descriptive statistics, which are things that we will cover later in this try, and then make some decisions using inferential statistics, which again, those are later notes that we'll cover. So, some different things that we should know. First, in a census, I gotta get my little pen out here. I'm gonna just type it actually, that'll make my life easier. In a census, measurements or observations from the entire population are used. Okay, we talked about that in class not too long ago, but a census is, they do this in the United States every 10 years, but they survey literally everyone in the US. Okay, if we use data from only part of the population, we talked about this being known as a sample. So for that, we say in a sample, you guessed it, measurements or observations are taken from part of the population. Okay, so those are hopefully, fairly obvious statements. Okay, now, when gathering data for a study, we want to distinguish between observational studies and experiments. In an observational study, okay, so there's little differences between these two things. Observations and measurements of individuals are conducted in a way that doesn't change the response or variable being measured. So I'll type that in there. Doesn't change. Okay, in an experiment, we do something, we give what's called a treatment, is deliberately imposed on the individuals to purposely observe a possible change. Okay, so you think about an experiment, this is common in the medical field. We give some sort of, anecdotal medicine or, injection or whatever the case might be. And then we study and see, okay, did that change things the way we thought it would change? Or did it not really change compared to the control group? Control group meaning the group we didn't give any medicine to. So there's some difference there. Observational studies, we're not trying to change anything. We're just observing. Experiment, we're trying to change something, and then we're observing to see, did it change the way we anticipated? Okay. So some different examples that we have. In 1778, Captain James Cook landed in what we now call the Hawaiian Islands. He gave the islanders a present of several goats, and over the years, these animals multiplied into wild herds, several thousand of them. Okay, they would eat almost anything, including the famous silver sword plant. So how could we test the theory that goats could be responsible for the decline in the silver sword plant? So um, would an experiment or an observational study be more appropriate? So in this case, we'd have to discuss what one would we choose? Would we choose an experiment to see, were the goats really the issue, or just do an observational study? Well, in this case, the best answer I would say is actually going to be an experiment. And how could we do an experiment? Well, perhaps we just section off a certain portion of land, and in that portion of land, we tried to say, observe one section where goats are allowed and one section where they're not allowed. And could we analyze and see the difference between how many plants are left? Did the goats make a noticeable difference, or was the amount of plants left similar in both areas? But we would want to do the treatment in this case would be like allowing goats in some areas, but blocking them off from others. Okay, so that's where the experiment, the treatment, we did something on purpose to try to tell if the difference was made. Okay. What are some things that could affect the validity or the results of our study? Well, what are some things that could impact what we had? Maybe how many silver plants were available originally. There could be some things about, weather or other outside factors that could have also affected our validity. So there could be other factors that could affect, how many plants are remaining or how the plants are affected. But in the study, like I said, we would want to be as specific as possible, trying to make sure when we set up our experiment, we should have 2 plots of land that are very similar. They should be similar in, soil, area, climate, how many plants were there to begin with. And then when we fence in one area and leave the other area alone, the control group, meaning the group we tried to keep the same, was not fenced in. And then the experimental group would be the one that was fenced in, and we would kind of try to decipher the similarities or differences between those two things. But to avoid or try to improve the validity of our study, the 2 areas would need to be as similar as possible. We want to try to keep the only variable being the fence. Because if there's a bunch of other variables now, that affects how valid our study is, because the other variables might have impacted the plants. Okay, consider the situation. Teacher claims that having a flexible seating chart will improve student learning outcomes. During the trimester, the teacher reduces homework, alters assessments, allows for flexible seating, and includes more project-based learning. At the end of the the students' learning outcomes were noticeably higher than previous trimesters. Can the teacher conclude that flexible seating increased achievement? Why or why not? Well, normally we would have a good discussion about this and hear your guys' ideas, but I guess I'll have to give you the short version. No, this is not a good conclusion. If we change 5 different things, we can't just assume that only one of them, in this case, the flexible seating, was the one that improved learning. How do we know that changing the tests didn't make learning better? How do we know that reducing the amount of homework didn't impact their grades? There's all these other things that we changed at the same time that would affect our outcomes as well. So long story short, we're trying to say, when we're designing an experiment, if we want to truly have good results, we want to analyze one variable at a time, or as few variables at a time as possible. Rather than 10 different things, try to focus on one. Did that one variable change things or not? Okay, then a different side note, this idea of the placebo effect. If you haven't heard of the placebo effect, basically it occurs or it happens when a subject or a person receives no treatment, but they believe they are in fact receiving the treatment, and then they respond well. So for example, this is common in medicine. Maybe there's a certain illness and we come out with an experimental drug and we say, all right, we're going to give this drug to XYZ patients, but then other patients that are going to be part of the study, because people usually volunteer for these experimental treatments, but if they volunteer for the study, half of the people maybe in the study are going to get the real medicine. The other half are going to get a sugar pill. It doesn't do anything. But the placebo effect says the people who got the sugar pill are responding well to the medicine, thinking that it's actually, improving their state of being, even though they didn't really get anything. Okay, so it's kind of a false positive, showing positive results even though, they didn't get the drug that they were supposed to get. Okay. To account for the placebo effect, patients are divided into groups. Again, we call the other group called the control group is the group that really hasn't gotten any change. Experimental group is the group that has changed. Control group is the group that remains the same. Okay, so after a while, we do this study. We compare the results, and we want to assess to see were our results similar or different. If the group that got no medicine ends up seeing the same results as the group who got medicine, well, then we can't really conclude that our drug did really much of anything. We didn't really see noticeable differences in the two things. Okay, now I know we're a lot of me talking again, which is not really ideal, but we're normally would have a little bit of discussion in class. I'll try to be as brief as possible and spare you some pain with some of these things. Okay, so here's a question. Can chest pain be relieved by drilling holes in the heart? For more than a decade, surgeons were using a laser procedure to drill holes in people's hearts. Okay, a recent research project at Lenox Hospital in New York conducted a completely randomized experiment to investigate this situation and see, was it legit? Okay, now we could discuss, what would that experiment look like? How would they do that? Would they drill a hole in some people's heart? Would they go in and fake drill a hole? And that's, if we were doing the placebo effect or trying to test for that, we would honestly have to do that, pretend that we did the surgery to drill a hole in their heart, but not actually do it, and then see if their results, compared favorably to those that we actually were performing the surgery on. Okay, so here's kind of how that grouped or looked. Like I said, we split into two groups: 149 patients that had laser holes in their heart, 149 that did not, and then we want to compare what was their pain relief and what were the results? Did we see similar things in each group of patients or not? Okay, the laser patients did well, but shockingly, the placebo group showed more improvement in pain relief. So this is one of those weird examples where we did a treatment, then we kind of pretended to give a treatment, and they actually did better. So that shows you maybe the power of your mind, how much, just thinking you had a procedure to help you can feel like you're actually improving. Sometimes people say this about like headaches. You have a headache, and as soon as you take an Advil or pop an Advil, your headache instantly feels better. Well, the medicine hasn't even kicked in yet. You just had the placebo effect of, your brain telling you, okay, I took medicine, my head shouldn't hurt as bad anymore. Now that doesn't happen to everybody, but some people feel that way. Okay. Sometimes it's difficult to control all the variables, like I was talking about before, that might influence a response. So one way to control some variables is through blocking. A block is a group of individuals sharing common features that might affect treatment. Okay, so maybe all these people have the same characteristics and could respond similarly. So we could look at certain groups. And a randomized block experiment, individuals are first sorted into blocks, and then a random process is used to assign each individual to one of the treatments. So for example, maybe I group people by age, and then I group people by gender or ethnicity or, various things. Or maybe I group them by predisposition to illnesses. Maybe all these patients in a certain block have chronic heart disease, or maybe this group of patients is all overweight. So I could block them, and then within each block, I could say, all right, half of these patients are going to get the experimental drug, the other half are going to get the placebo. And now we could kind of assess, how did the people who were overweight, did they respond similarly to getting the drug or not getting the drug? And then I could kind of compare, maybe being overweight in and of itself affected certain things. So there's a lot of variables that can go into certain studies, especially medical studies. Okay, so I'm gonna look. You can pause this if you need to, but it's in your notes. But the control group again, we try to avoid some of these. The control group is used to account for influence of other known or unknown variables. So maybe there's variables that we didn't really know would affect our study before doing the study, but then they end up showing up as something that caused certain things to occur. Okay, so those variables are called lurking or confounding variables. Okay, and again, they can show up by things that we didn't account for in our control group. Okay, now A lot of talking, I know. Oh boy, where did I go? Once you decide whether you're going to use sampling, census, observation, or experiments, a common means to gather data is to ask questions. Okay, what types of survey questions or responses can we look for? That's one issue that we might have. So we got to think about the types of survey questions. What could a response could we look for, ask for, etc. So there's all kinds of different things. You know, we got to be careful about how we ask questions. We don't want questions to be leading. You know, for example, I might say a question would be, if I skewed things, kind of like I talked about in class, you know, in 1.2, if I asked certain people coming out of the liquor store if they like the liquor tax, well, it's probably a good chance that they're going to say no. We could also say within certain survey questions, you could word questions very poorly to get people to answer the way you want. For example, maybe I say, the new school, if you are for the new school, it's going to cost you thousands of dollars in tax money every year, extra out of your pocket. So do you support the new school? Well, the way I phrased it, or the things I told you about before, you know, I could phrase things negatively to get a negative response, or I could phrase things positively, where maybe, what if I phrased it as said, if we built a new school, we would have great facilities and opportunities for people in the community to have access to weight room, fitness center, uh, better technology for our students, blah, blah, blah. Do you support the new school? Well, now I might say yes. So again, depending on how you phrase things, you know, you might elicit different responses. So you have to be careful with how you word questions to try to be not biased. Now, the types of questions we could look for, you know, you could look for yes or no responses. You could look for multiple choice where you give them options to pick. You could give Likert scale responses, which is basically saying like, on a scale of 1 to 5, 5 being the best, 1 being the worst, how would you rate blank? You know, so there's a lot of different ways we could conduct a survey or ask questions. Some issues or pitfalls that you have when using a survey, well, you could have people who don't respond. You could have people who lie on purpose to try to, you know, give you the answer they think you want. You could have, you know, faulty recall where people don't really remember accurately an event and they could respond inappropriately or incorrectly. You could have hidden biases, and that's what I was saying before, where the questions might be worded poorly or vaguely. You know, if I say words like often or occasionally, everyone might interpret those words differently. You know, I might say, how often do you go to the doctor? Well, that's okay. That's not the best example. Maybe the question is, what would you say is your completion percentage on homework? Would you complete it frequently, often, occasionally, seldom? Well, everyone might interpret those words differently. Maybe I think occasionally means once a week, and somebody else means occasionally means 3 times a week. I don't know, but everyone's interpretation might be different when you use vague words like that. If you're interviewing people in person, then the interviewer who's asking the questions might lead people to certain answers. You know, I might say things in the tone in which I say them might influence how you feel like you should respond. And then voluntary response, we talked about this one in class too. You know, if you just allow people who feel like responding to respond, you might get people with strong opinions as the only ones responding to your survey. You got to be careful with some of those issues when you're doing survey questions. Okay, and that's kind of, this is what I was just discussing, so you can kind of read through those as well. Okay, then sometimes our goal is to understand the cause and effect of relationships between 2 or more variables. Again, such studies can be complicated by these ideas of lurking variables and confounded variables. So we've kind of talked about some different techniques, observational studies, experiments, and surveys, which technique is the best? Should you do an observational study? Should you do a experiment? Should you do a survey? Which one is the best? Well, easy answer. It depends on what you're doing. There's not a best one all the time. It depends on what you're trying to study and what you're specifically looking into that impacts which one is the best. So surveys might be the best choice for gathering information across a wide range of variables because it's quick, it's easy. You can include many questions in a survey, so you can get a lot of stuff done or a lot of data gathered at one time. Okay, that's a benefit of surveys. Observational studies are the next most convenient because you just have to observe. So that's pretty easy. Protocols for taking measurements or recording observations need to be decided beforehand. So if I'm looking at weights of watermelons, I need to decide how am I going to measure them, to what decimal place, am I using ounces, inches, or not inches, if I'm talking about weight, ounces, grams, whatever, pounds. You'd have to decide all those things ahead of time. Experiments are the most stringent, they're the most restrictive, so they're hardest. But even though they're time consuming, expensive, and difficult, they can provide a lot of valuable insight. So they can be very worthwhile. They could also not really give you any results that you wanted. So they're the most difficult to conduct. But again, there's not a right answer of which one's best. It just depends on the scenario. Okay, number of requirements. Variables is a lot more limited in experiments. That's what I was saying before. We kind of want to limit to as few of variables as possible to get relevant data from our research. Okay, now I know that's a lot of talking, a lot of words. As you're looking through the questions, you guys work together, and I think the more you discuss, the more you're going to kind of learn. And we'll go through things on Monday again as well. So do the best you can with some of those questions.